Today we're going to continue our discussion in 12.1 and 2 on congruence through constructions. Last time we had done two constructions. Do you guys remember what they were? Circle and segment. So a congruent segment and a circle with a given radius. That's what we had created last time. So today we're going to move on into triangles, congruent triangles. So two figures are congruent if it is possible to fit one into or onto the other so that the corresponding parts are congruent. Specifically for triangles, we would often use the phrase, I know you've heard it before, corresponding parts of congruent triangles are congruent. And we'll abbreviate it to CPCTC. Right? When we name congruent figures, we keep the vertices in order so that congruent parts correspond. So if angle A corresponds to angle X, then they need to be in the same location when we write them down. If angle Y corresponds to angle Z, they need to be in the same location when we write them down, and so forth. So in order for triangles to be congruent, they have to have three congruent sides, not congruent to each other, but congruent to the other triangle, and three sets of congruent angles between them. All right, the first congruence theorem for triangles is the side-side-side congruence theorem. It says if all sides of one triangle are congruent to the corresponding sides of another triangle, then the triangles are congruent. So in other words, this image right here, what we're saying is that this side is congruent to this side is congruent to this side, and this side is congruent to this side. And if all we know is that three sides are congruent, the triangles must be congruent. In other words, it forces the angles to have the congruences we know that they should have. Forces it to happen. Okay? So this is one of our correspondences, or congruence theorems. The second one is side-angle side. So it's two sides and an included angle. Included means between. It's the angle between them. If they are congruent to the corresponding parts of another triangle, then the two triangles are congruent. So it doesn't matter which ones I mark. I'll mark the one on the bottom and the one on the top left. And then I need the angle that's between them marked. So that's these angles right here. So again, if all I know is that the two angles that are, the two sides that I have marked are congruent and the angle between them is congruent, then those triangles are forced to be congruent as well. That's sufficient to give me the rest of the congruences that are there. The next one is a special case, okay? It only works for right triangles. Right? So it's called the hypotenuse leg congruence. It says if the hypotenuse and the leg, one of the legs of a right triangle, are congruent to the corresponding parts of another triangle, then the triangles are congruent. So hypotenuse is always the side across from the 90-degree angle. That's this one. And I already have the angles marked as 90-degree angles. That's important, otherwise the hypotenuse doesn't make any sense in the context, right? And I need one of the corresponding, or one of the pairs of legs to be corresponding congruent as well. So I'll mark this one, but it could be the other one. It doesn't matter. What I want you to notice is that this is not the same as side angle side. What's different that this, as it's marked, than side angle side?
The angle in between the two sides is not the one.
Right. It's a different angle. It happens to be an angle on the outside of it. And this is unique when the angle on the outside is 90. Okay? You can't guarantee that this will happen if it's not a 90-degree angle out there. And we'll see an example of that. I don't know if it's today or later, but we will see an example where it falls apart if it's a different angle measure. But for 90-degree angles, it works. Hypotenuse and one leg. All right, so what we're going to take a look at on this example is finding how to writing a pair of congruent triangles. So on number one, there are congruent triangles there. We're going to figure out what the congruent triangles are, and we're going to write them correctly to make sure that things line up. So, do you see the corresponding triangles, or do you see the triangles that correspond with their angles and so forth to give you congruent triangles? Yes? Okay. They're the thin one on the left and the thin one on the right, if you will. So this is one of them. I'm going to mark it in red. And I'll mark the other one in blue. Oops. Okay. So these are my two triangles that are congruent to each other, right? Why do you know that they're congruent? What postulate, which one of those congruence arguments actually works here? Side, angle, side. But there's only one side marked. They share one. The side that they share would automatically be the same length for each triangle, right? So if you will, sometimes I'll have people that will like to mark that side just so that they remember and they can see the arrangement and the fact that the angle is in fact between them, right? That side that I marked in the middle there is the same for both triangles. So the next thing we're going to do is we're going to write down the congruence that exists. So the first triangle, tell me any order you'd like the vertices of the red triangle. A, B, D. And we're going to put the congruent symbol between them and a triangle. Okay, the triangle for the blue triangle, the order of the vertices matters. I have to match them up correctly. Which angle corresponds to angle A? C. So it must be listed in the same spot where I put A. Which angle corresponds to B? It happens to be B. Doesn't always happen, but it did on this one. And the angle that corresponds to angle D from the red triangle is D in the blue triangle as well. So if you put the triangle coordinates, the vertices in a different order, that isn't correct. The order matters. All right, there is more than one answer on the second picture here for triangles. So let's take a look at what we have, and somebody offer up for us a suggestion of what congruent triangles you see in the second diagram. Okay, ABD, I hear Amy saying. I heard somebody else saying side, side, side. What was the triangle that's congruent to my blue one right now? All right, so over here on the far right, yeah? So we've got this one over here. And why is it congruent? Side, side, side. Okay, so let's write the congruence down. Blue triangle, what do you want to label it as? A, B, D. I think some of you like alphabetical order. I'm just guessing. And the other triangle then? All right, so the C corresponds to A, the B corresponds still to B, and the E corresponds to D. And if you aren't sure, because they actually don't have any angles that are marked, right? You can also think of it in the terms of the sides. This side, AB, is right here. So the corresponding side that goes with it is BC, and it has to be in the same, or CB, whatever, it has to be in the same location, and it is. Do you see that for the sides? They match up as well. Okay, I'm going to take all the markings that I just did on my triangle off, because there's another set. Okay, let me write them down, and then we'll make sure that you have them right. Tell me what you have, Leah. Okay, so let's mark them. ABC. I don't think that one worked. Did I write it down wrong? Did you mean ABE maybe? Because ABC is the big outside triangle, right? So it's not that one. So let's try again. Ah. All right, let's just do this. What's another thought?
ABE and CBD.
ABE and was that you, Lacey? What did you say?
CBD.
CBD. Okay, so let me mark that one. ABE would be this one in green. I know I'm not hitting them quite right, but you still get the right idea, I think. And then CBE would be the one in pink. Okay, so if those are my pairs, why would those match up? Side, side, side. It's a little more difficult to prove this one because the sides are not exactly marked. What side would require a little bit more argument as to why they're actually congruent?
The AD and EC.
Yeah. Down here at the bottom, what I have is I just have that this piece is marked congruent to this one, right? But the triangles that we just referenced need this piece to be equal to this one. Sorry, you can't see my black on there. Let me try that again. How about that one? Now they are, right? because they have a piece on the outsides that are congruent, and what can you tell me about the piece in the middle? They share that piece, so it's automatically the same. So it is side, side, side. It is true, but you'd have to argue it a little bit more to actually make convincing the fact that the bottom actually has the two congruent pieces that you're saying that it
How
does.
would you argue that?
You would talk about the fact that AD plus DE, like the segment itself, is equal to the segment AE. So something like, let me write it over here. AD plus DE, these are the measures, remember, not the actual segments, is equal to AE. And not A, is it C over there? Yeah. CE plus DE is equal to CD, like this. Because what we want is we want these two on the right to be the same. We know that AD and EC are the same. And then we know that the DEs and the DEs are the same. So the results have to match. It's arithmetic is what it really is, because I haven't written the segments on top of it. But that's what you would argue. You would talk about the segments being added together, the segment lengths being added together. So I'm going to write down this is side, 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 which you're totally right, but it requires additional, we'll use the word work, proof, argument, whatever's going on with the context of the question that's being asked. Okay, so we have an example here of side, side, side. That was the first one, and then we had two examples of side angle, I'm sorry, we had an example of side angle side. That was the first one. We had two examples of side, 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 which was the second one. Okay, there's a couple other congruence theorems we're going to take a look at. The next one is angle, side, angle. So we have two angles and the included side of one triangle corresponding to two and the included angle of another. So again, my argument doesn't matter on the angles themselves, so I'll mark the top one and the left one. And included means it needs to be in between those two angles. So which side is in between the two angles, visually speaking? There's no hypotenuse because there's no 90-degree angles here. Yeah, top left. Let's go with the directions. That works. Megan's right. I think top left is a good description. So this one's the one I think everybody's trying to describe for me, yeah? Okay, so this one's included. It's in between the two angles that are marked. So again, if I have that visual given to me, it is sufficient to know that both the triangles are actually the same size and shape. Angle, angle, side. Okay, so this is two angles, but it's not the included angle. It's not included between the angles. That's what I meant to say. It's a different side. So I've got two angles. I'll mark the same two that I marked on the last picture. And it's not the one side that we marked last time. It's one of the other ones. That's what this is saying. So we'll just mark the bottom one. It doesn't matter, but one of the other ones is marked. That's also enough information for this to work. All right? So what that really tells you is that when you take these last two theorems and look at both of them is, as long as I have two angles and a side, I'm good to go. It doesn't really even matter where the side is, right? Because I had one theorem that said the side could be between them, and now I have a second theorem that says the side could be either of the other ones as well. So two angles and one side is enough to actually make this work. But not everything works. In fact, there are two that do not work. The first one is angle, angle, angle. And you can see in a picture, I've got triangle ABC and triangle EGF. They're marked correspondingly. I know they're not colored on your paper because it's probably printed for most of you in black and white, but they're colored on my screen. Angle B and angle G are marked in red, angle A and E are in purple, and C and F are in green. They're the corresponding angles that are marked. But these triangles are definitely not congruent, right? Yeah. There is a relationship name between them. Does anybody remember what it is? They're similar, and we will talk about those later in another chapter, but they're not congruent. The second one that doesn't work is side-side angle. Now we had side angle side, and that was cool. But side-side angle says that we have two sides and the angle that's not between them, or an angle that's not between them, right? So this picture feels like funny. You're looking at it and going, I don't know what I'm looking at in this picture, so let me give you some information. The side, or the angle that they share, is angle A. You know what, let me mark the two triangles. Let me start there. One triangle is triangle ADB, the pink one. And my other triangle is going to be triangle ACB, the red one. Okay? I'm trying not to connect it because it just overlays with the... Sometimes technology is a little too helpful. It tries to connect dots and so forth. So they share an angle. What angle do they share? A. They both have angle A in them, so that's the angle. They also share two side lengths, or side lengths that are the same length. So what is the... They share one side length completely. What side do they share? AB. Down here at the bottom, they share this side. And they also have this side and this side that are marked congruent. So there are two side lengths that are congruent, and they've got an angle that's not between them. And there's actually a picture drawn here of the two triangles that could be created, and they're definitely not congruent. One's acute and one's obtuse, right? So that's no good. So it doesn't work to have side-side angle. And I don't know about you, but in geometry, when I learned about this one not working, I remember what the teacher told me as to remember why this doesn't work. Do you guys remember? Yeah, if you change side-side angles notation around it, it spells a bad word. Right? This right here is what we're talking about. Okay, so that's how I remembered it, because that's what she told me when I was, in 9th grade or whatever it was. Okay? So side-side angle does not work. Okay. Have one more set of examples, 3, 4, and 5, and then we're going to actually do some constructions. So our set of examples says for each of the following, find at least one pair of congruent triangles and tell why they are congruent. So we don't have any markings of letters on these, so let's mark them all together just so that they all match. Let's call this at the top A, B and C. C is the right angle, and then D, E, and F is the right angle. All right, so we only have two triangles here, so clearly one of the triangles is triangle ABC. So using our corresponding parts, which angle is congruent to angle A? It's E. And which one, oops, I need a triangle here, not an angle, sorry, triangle, E. Which angle is congruent to B? D, thank you, and to C? It's F. Okay, so this is the correspondence that matches up. The only angles that's actually marked, we kind of went through it, was angles C and F. Those are the ones that are marked congruent, right? So we do in fact have those in the same location. The other two pieces we get by determining, or we determine by looking at the different side lengths that are congruent. Which argument of the 6 or 5, I think it was 5 of them, actually works for this one? Hypotenuse leg. Hypotenuse leg only works for right triangles, and this is a right triangle. Yeah? And the hypotenuse is in fact marked as congruent, and the two legs, a pair of legs, are marked as congruent. So this is the hypotenuse leg theorem. How about this one? We've got a 90-degree angle, so that's cool. So that might mean that we've got hypotenuse leg here again, right? We have AC and CE both marked. And there's nothing else marked. What's that?
You can mark the angles that meet C.
Okay, so right here, Alyssa?
Yes.
Okay. How do we know that those are congruent? You're correct, they are. Yeah. They're vertical angles. So that's actually something we did in Chapter 11, right? Chapter 11, we talked about vertical angles, and vertical angles are always congruent. And it's actually not a definitional thing. It can be proven true from the vertical angle definition. But it is a fact about vertical angles. So we do have that. So if we were wanting to argue about why this works, we'd have to talk about the fact that we know that there's vertical angles here, right? Like that's part of the why it works. So as we're sort of thinking about this, I'm not asking you for a full out proof here, and the question doesn't ask for that either. But it is good to recognize that if you were asked to justify why, we would actually be able to say that angle BCA is congruent to angle ECD. These are the angles that I'm talking about because they're vertical angles. Okay, that's the third piece of information that I need. I need sides, I need angles, that's one of the angles. So let's go ahead and do the triangle now. What is my triangle arrangement? I've got an ABC. So triangle ABC, let's match things up. What angle is congruent to angle A? E. And to angle B? D. And to angle C? C. So that's my correspondence. Which of my 5 arguments is the reason why? Is it hypotenuse leg here? It's actually not, because I don't have a leg marked, right? So which one is it? Angle, angle, side. So you're right, Hannah, it is angle, angle, side. How did you know it was angle, angle, side and not say angle, side, angle?
Because it said the angle's not between the two sides. The side's not between the two angles.
Right. The side that is marked is not between the angles. Okay? So this is angle, angle, side. All right, you guys ready for the next one? It's the more unusual in terms of the picture than the other ones have been. All right, so let's see, what do we have here? Let me see if I can remember what I have marked here. I think the marking is actually just for the side AB. This is what happens when you get pictures with sides that overlap. It's hard to know, but I'm pretty sure the marking is just for the sides that overlap. All right? We'll hope for that and go with it and see what happens. Okay, we have a couple of triangles here that are congruent. Let's see if we can list the angles and so forth, the things that we have. We know that we have angle AEB congruent to angle AEC, sorry, let me get the letter in there right, AEC, congruent to angle ABD. That's the pink angles that are marked, and we are also told that AB as a side length is congruent to side AE. That's it. There's only 2 things marked on this picture. What's the piece that I'm missing? What is it? There's another angle, actually. There's not another side here marked or known. What is it?
Are we sure there's not 2 sets of angles we can mark?
There is another set of angle. We just have to mark it. What is it?
They share A.
They share angle A, don't they? Yeah. They share angle A. So we actually know that angle A is congruent to angle A. And I am just going to write it as A because there's only one angle that has A as its vertex in this particular triangle. Or set of triangles, this diagram. Okay, so these are the 4 pieces of information, sorry, 3 pieces of information, I can count, that are actually the same. We just have to decide now which triangles are that we're going to write down and why they're congruent. So let's do the triangle part first. One of my triangles is AEC. All right, so what angle is congruent to angle A? A. All right, and then what angle is congruent to the angle E right here? It's B. So we're going to put B next. And what angle is congruent to angle C? D. And what is the justification? Which of the theorems works for this? Angle, side, angle. I agree. Because this time the side is actually between the 2 angles that are marked, yeah? This one is angle, side, angle. All right, pretty good so far? All right, we're going to shift gears a little bit. We're going to do some constructions. All right, so the constructions that we have here are posted. I mentioned this last time. They're posted inside of Moodle Rooms. So if you want to go back and look at how in the world did she do that one again, you can go watch it. But it won't be me. It's a separate video outside of the video of this particular lecture, and it'll say video 3 and it'll have a description. There'll be a video 4 and so forth, and we will have all of our constructions on there. In fact, they're all on there that way right now. So we're starting now with video number 3. We're going to construct a triangle congruent to a given triangle using lengths of 3 sides. So what we did is we had a theorem that said if all I know is 3 sides, the triangles have to be congruent. That's what we know. So we're going to actually construct it showing why that actually works visually, like conceptually when we're drawing it, it has to make sense.